Hello, hopefully that is working. Okay. Actually, hi everyone, this is Adam again. This is the seventh video of the series of paper 1 for Leaving Cert Maths. So today we're going to do Algebra 3, which is basically how to solve some sort equations, so with square roots, and then using inequalities and stuff like that, and going on about absolute values. So this will probably go over 2 videos, I would say. But one thing I want to do anyways is is simply the square roots. So that's the main thing. So the last time we were looking at how to solve different equations, so this is no different. So this one is going to be something like, if you have root x plus 3 equals 4, how do you solve this? So in this case, you're just going to square both sides, okay? So now you could guess, because you know the square root of 4 is root 16. And this implies then that, therefore, you need that x has to equal 13, okay? But really what you should do is you should square root both sides, okay? Square both sides. So if I square the left hand side, I just get x plus 3. Square the right hand side, I get 16. And this gives me x equals 13. So either square both sides, or you could do this method as well, change the right hand side to a square root, but typically it's a lot easier to square things. It's just having square roots kind of around the place is just it can get confusing. So yeah, I'd always just get rid of it. So we can do a little bit of a harder problem. So something like root 4x minus 3 minus 2x plus 1 equals 0. Okay. Now for a problem like this, what you need to do is you need to, again, you want to square both sides, but the problem is that this term, when you square the left hand side, you're going to have a square root multiplied by the stuff in yellow, and you don't want that. You want to get rid of the square root completely. So see back up here, the way when I squared both sides, the square root was completely gone. I want to do the exact same thing here. And the way you do it is you isolate the square root, so you just leave it on its own. So what I'm going to do is I'm going to bring the yellow stuff over to the right hand side. So it's going to leave me with 4x minus 3 is equal to, if I bring the yellow stuff across, I get 2x minus 1. Okay? So now I can just square both sides and get 4x minus 3 equals 2x minus 1 squared is 4x squared minus 4x plus 1. So now I'm just going to start solving these a little bit faster than what I used to. I've done the introduction on how to solve these and how to square things. So now it's just going to be when I'm doing them, I'm just going to kind of solve them a little bit faster. So this is going to give me 4x squared minus 8x plus 4 equals 0. I can divide both sides by 4 and get x squared minus 2x plus 1 equals 0. This gives me x minus 1 to be squared equals 0, or this means x equals 1. So x equals 1 in this case, okay? Yeah. So I'll do one more. This is going to be a little bit harder. This is going to be a lot more. Okay, this is going to be a lot more long-winded, but Sure, look, it'll be fine. So I can say square root of 6x plus 4 minus 1 equals root 3x plus 1. Okay? So now, for something like this, you could, in theory, guess if you wanted to. So just off the bat, the answer is x equals 0. Okay? So it's always to be mindful. A lot of people say that, in the state exams, that if you just write the answer, you're going to get 0. That's true if you're wrong. But if you're right, then you're completely fine. So like for this one, I don't have the solutions with me, but I just looked at it and I was like, well, if x is 0, then I get the square root of 4 on the left-hand side. That's 2. 2 minus 1 is 1, grand. And on the right-hand side, I get the square root of 0 plus 1, which is 0, which is 1, sorry. And the square root of 1 is 1. So the solution is x equals 0. But I'm going to solve this the same way that we used to, but it's just if you do, if you are able to spot it, then fantastic. But if you can't, then don't worry about it. So here I can square both sides. If I square the left-hand side, I'm going to get 6x. I don't know why that keeps coming up. 6x plus 4 minus 2 root 6x plus 4 plus 1 equals 3x plus 1. Okay, so now, again, I'm going to isolate the square root. So what I get is, it's going to be 2 root 6x plus 4 equals. So this is going to give me, so first of all, that 1 and that 1 will cancel. When I bring the 3x to the left-hand side, I'm going to get 6x minus 3x, so 3x. Plus 4, yeah, just plus 4. Great. So now I want to again square both sides, because now I have the same thing that now I only have one square root, so now that's a lot better. So if I square both sides, I'm going to get 24x plus 8 equals 9x squared plus 24x plus 16. This gives me 9x squared. The 24x is cancelled. So I'm just left with 9x squared. Oh no. Did I make a mistake here? This should be 16. Sorry. It's my fault. 16. So this again cancels. So I'm left that this equals 0, and this means that x equals 0 is your answer. Okay? So that's how you do those. And sometimes as well, you can get two answers. So see here, the way we got a quadratic. Now, the answer was trivial, that the answer was just 0. But let's say that isn't the case. Then what you would do is you would just solve it. You'd get two answers using the minus b formula or factorization, whichever you prefer. And then what you would do is you would plug it back into the original equation, which is up here. You would plug it back into this equation and just see which answer is correct, because only one of them will be. Okay, so always when you get two answers, go back and check and see which one is actually correct. Okay, so now you have inequalities. So what is an inequality? So an inequality is just a statement. This is less than. This is greater than. This is less than or equal. And this is greater than. Or equal. Okay? So it could be something like this. So it could be 2 is less than x is less than or equal to 4, and x is an element of n. And you would like to plot this. So you draw your number line. Say here's 1, here's 2, here's 3, here's 4, here's 5, and 6. So how do you draw this? Well, first of all, you say, what can x be? So x is an element of n. So what is n? N is your natural numbers, your counting numbers. So 1, 2, 3, 4, 5, 6, 7, and so on. So x has to be bigger than 2. So this statement here says that x has to be bigger than 2. And what does that mean? That means that x cannot be 2. Why? It can't be 1 and it can't be 2 because you need to be bigger than 2. Now, 3 is bigger than 2, 4 is bigger than 2, 5 is bigger than 2, and 6 is bigger than 2, so that's fine. But x has to be less than or equal to 4. So the numbers that you could have are, at the minute from the first inequality, is 3, 4, 5, 6, 7. Is 3 greater than 2 and less than 4? Yes. So this is one solution. Is 4 bigger than 2 and less than or equal to 4? Yes. Is 5? No. 5 is bigger than 4 and therefore it's not less than or equal to. So that is how you would solve this one. Okay? It could be something like minus 4 is less than minus x plus 2 over 3 is less than or equal to minus 3, and x is an element of the reals. So real numbers are all numbers, okay? So, first of all, you want something that looks like this. Okay? So you want just x in the middle. You don't want any minuses, you don't want any fractions. So, first of all, I'm going to get rid of the fraction. So what I'm going to do to get rid of the fraction, I'm going to multiply everything by 3. So if I multiply everything by 3, I get minus 12 is less than minus, so remember, that's minus the whole thing, so it's minus x plus 2 less than or equal to minus 9. So I get minus 12 is less than minus x minus 2 less than or equal to minus 9. Now, I want to get rid of this minus 2, so I'm going to add 2 to everything. So you can act as if an inequality is like an equal to sign. Okay? Because if I said that if A is less than B, then obviously A plus 1 is less than B plus 1. That's still true. Okay? So that's all I'm saying here. So I can add 2 to everything. And if I add 2 to everything, I'm going to get minus 10 is less than minus x is less than or equal to minus 7. Now, we need to get rid of the minus. So I'm going to multiply everything by minus 1. This gives me plus 10 plus x and plus 7. Okay? And the biggest part, these inequality signs flip. They flip because I multiply by a minus. Okay? So you get that inequalities flip when you multiply by a minus. Okay? So, and to show you this, it's like saying that 1 is less than 2. If I multiply by a minus, I get minus 1 is less than 2, which is clearly sorry, minus 1 is less than minus 2, which is clearly incorrect. But if I do minus 1 is greater than minus 2, then that's correct. Okay? So when you multiply by a minus, the inequality flips. Alright? So that's what that is. Okay. So that's your linear... Oh, sorry, I still need to solve this. Okay. So I want x to be greater than or equal to 7 and less than 10. So it's going to be 6, 7, 8, 9, 10, and just 11. Okay? So remember, x is an element of the reals. So it can be all numbers. So, first of all, can x be equal to 7? Yes. Okay. Can x be equal to 8? Yes. Can x be equal to 9? Yes. Because 9 is bigger than 7 and it's less than 10. Can x be equal to 10? No. Why? Because x has to be less than 10. Okay. But can x be equal to 9.9? Yes, it can. Because again, x is an element of the reals, which means it's any number. Any number, okay? The real numbers are the real line, so that's minus infinity to plus infinity, and it's all numbers. It's halves, it's square roots, it's pi, it's, you know, whatever, it's everything, okay? So you do this. That's how you do it, okay? And then you draw lines here, like this. The reason I'm drawing the line here is basically saying that it can be all numbers between 7 and 8. It can be all numbers between 8 and 9. It can be all numbers between 9 and 10, but not 10. Because it can be 9.9. It can be 9.99. 9.9999999. It just cannot be 10. Okay? And that's why this circle is left open to specifically say that it cannot be 10. It can be, you can get as close to 10 as you like, but you cannot pick 10. Okay? So yeah, hopefully that's okay. Now, I'm going to do a couple of quadratic inequalities now. So what you want to do is, I can do something like this. So let's say 2x plus 1 over 3x, x. X plus 3 is going to be less than 1. And x is not equal to minus 3. This here, that's only written basically because the fraction down here. Okay? Because if x was equal to minus 3, then we'd be dividing by 0, which we cannot do. And that's why in the question you specifically get this. And you have to be very careful because it comes up in the leaving cert a lot. Just to be careful that if you get two answers, okay, so sorry. When you solve this inequality, you will get two answers. You need to be mindful as to whether x can be equal to minus 3 or not. Okay, so it'll state in the question, x cannot be equal to this or whatever. And then you go and you solve it and you do your inequality, and you might say, oh, in your inequality for your answer, you might say, oh, x is less than or equal to 7. But at the start of the question, it said x cannot be 7. And you will lose a mark for that. So do just be careful. It might come up in this question, I'm not too sure. I don't know what the solution is yet, I haven't done it. But yeah, sure, look, we'll see anyways, but just to be, to say that before I do it. Okay, now, before I'd always say, what is difficult about this question? The fraction. The fraction is hard. The fact that you're dividing by x minus 3, that's what makes it hard. So get rid of it. So multiply by x plus 3. You can't do that in this case. And the reason is because you don't know, is x plus 3 positive or is it negative? So you do not know if this should change sign or not. should it point to the left or should it point to the right? Because remember, if you multiply by a minus, the inequality flips and it faces the other way. And if you multiply by x plus 3, you do not know which way it should go. Okay? So, we are going to multiply by x plus 3 squared. Okay? Because this thing is strictly positive. So we know we're multiplying by something positive and that covers us. And that's basically the trick of it. The rest of it is just kind of maths. So when you do it, you get 2x plus 1 multiplied by x plus 3 is less than squared. Now if I multiply these out, I'm going to get 2x squared plus 7x plus 3 is less than x squared plus 6x plus 9. Now, this is just me personally. I always want the x squared to be positive, and therefore I'm going to bring this guy to the left hand side because I have more x squareds on the left hand side. That's just a personal preference. If you want to do it a different way, you can. I just prefer this way. So when I do it, what I get is I'm going to get x squared plus x minus 6 is less than 0. Now for this part, you want to factorize. So if I factorize this, again, this is minus, which means this number and this number have opposite sign. So one is plus and one is minus. And in this case, it's going to be plus 3 and minus 2. So we get that x plus 3, x minus 2 is less than 0. So now you want to know, when does that happen? So when exactly is it less than 0? Okay? So when does this become 0? This becomes 0 if x equals minus 3 or x equals 2. Then this thing equals 0. So now what you do is you draw your graph. Okay? So if I draw it, so now what I'm drawing is I'm drawing this because I want to know what values of x make this less than or equal to 0. Okay? So if I draw this, now hopefully you will remember here we have a positive number of x squared, which means the function goes up. The right arm goes up. So it's like a happy face. In a quadratic, if it's negative, if the number in front of the x squared is negative, it's a sad face, it points down. Here it points up. And we have that the two roots are going to be x equals 2. They're 2 and minus 3. So the graph is going to look something along the lines of this. Like this. And now you might be sitting there and saying, well, hold on, what part of the graph do we actually want? We want to know, when is this less than 0? Okay, so this is what we want. Okay, so it's only less than 0 we care about. And so you say, okay, grand, what x values will give it less than 0? So now specifically less than 0. Okay. So specifically less than 0, x needs to be greater than minus 3 and it needs to be less than 2. So x basically needs to stay within this here, okay? Alright, see, now that's grand, but let's just say back up here we got an equal to sign. So it's less than or equal to. Then down here we would have less than or equal to and less than or equal to. And see, this is when you have to be careful. Because here you're saying that x can be equal to minus 3, but up here you specifically said that it could not be minus 3. And therefore here, you would have to get rid of it. And you'd have to write this instead. And that would be your final answer, if it was less than or equal to they were looking for. Okay? So hopefully that makes sense. Yeah. Okay, and now you want, so we're going to do the absolute value of the modulus next. So the absolute value and the modulus is really not bad. It's just if you have the modulus of x, you draw it like this. Okay. That's the modulus of x. The modulus of x, you can think of the size. Or in quotations, just don't care about. About the minus. Okay? So you basically just forget about the minus. So see here, the modulus of x, that's, if I drew the y equals x line, so that's y equals x. But here you have, this is when it becomes negative down here. But you see, you don't care about the negative values, and therefore you just push them up here instead. Okay? So that's what the magnitude means. And you might be saying, well, hold on, magnitude, what do you mean by magnitude? Stuff like speed, how fast are you going? That's a modulus. Because you'd never hear of someone saying, oh, I was traveling minus 60 kilometers an hour. That doesn't make any sense, So if you're on a road and it's a 60 kilometer zone and you're going 60 and a car coming against you is going 60, well, if you're going plus 60, then the other person has to be going minus 60 because they're coming against you, they're in the opposite direction. So that's why there's a minus. But here we're just saying with the modulus, we're just saying we do not care. Okay? So it could be something like solve one of the modulus equations. So it could be something like solve maybe the modulus of x minus 4 is greater than 3. Okay? Now, you can square this if you like. Because the modulus basically is just the minus sign. It just gets rid of the minus sign. But if you square both sides, you actually don't have to deal with the minus sign. So I might do that now, and then I'll do it a different way in a second. But you can just square both sides. So if I square both sides, I just get x. So basically this thing is equal to x minus 4 if x minus 4 is positive. So if x minus 4 is already positive, then it just stays positive. But it's equal to 4 minus x if x minus 4 is less than 0. Okay, that might look a little bit stupid. Basically what this part here is saying, this is saying if the answer is minus, then we just take the positive. Okay, that's all that thing is saying. Let's say if x minus 4 is equal to minus 7, then we just take 7. That's all that's saying. But x minus 4 squared is equal to 4 minus x squared. Okay, and that's the thing to note, that they are both the same thing. Therefore, I can just square the thing on the left, and then all of a sudden, all my problems are solved. So I can just square it, and I get x squared minus 8x plus 16 is going to be greater than 9. So x squared minus 8x plus, plus 7 is greater than 0. This factorizes into minus 7 and minus 1. So we get that x equals 7 or x equals 1. Okay, so what does that mean? Again, you draw this equation out. All right, so if I draw it out quickly, again, in the exam, I highly recommend you just draw a quick little diagram. Doesn't need to be perfect. Just to give you an idea, again, the number here is positive, which means it's upward facing. So it looks like this. Okay? And, sorry, I should have written that down here. And this thing is greater than 0. So these are the points you want. Okay? So you want x here and you want x here. So you want x to be less than or equal to 1 or x to be greater than or equal to 7. Sorry, not 0. 7. So that then is your answer. Okay? And then if we plug that back into the original equation, so the original equation is just the magnitude. It's just the magnitude of x minus 4 is greater than 3. See, this is where you could have gotten... oh wait, sorry, did I change that? No, I'm sorry, that's my fault. Sorry, see here? They shouldn't have equal to's. The reason they shouldn't, so here, these shouldn't have equal to's. The reason is because all the way up, you're using strictly less than and strictly less than, and therefore those should be strictly less than. If you're sitting there and you have no idea, just guess whatever inequality they give you, use that one. So here, we're saying if x is less than 1, the modulus should be greater than 3. So just take it. Take x equals 1. We get 1 minus 4. This equals minus 3. Again, you just get rid of the minus, so it's just equal to 3. So it's equal to 3 if your answer is 1. And then less than that, you'll get greater, that's fine. And if I plug in 7, again I get 3. So that's another way you could solve for these. Basically, you solve this equation for 3. And then you kind of, not common sense, but you think about it and say, okay, well, do I want it to be bigger than 7 or less than 7? Okay, grand. Do I want it to be bigger than 1 or less than 1? And then you just see, because if you weren't sure and you're sitting there and you're like, oh, do I want x to be bigger than 1 or less than 1? Okay, let's say if you want it to be bigger, plug in 2. If I plug in 2, I get 2 minus 4 is minus 2. The modulus of that is 2. That's not greater than 3, and therefore I don't want greater than, I want less than, So you can solve it that way too. Yeah. So again, you could be asked to solve something like this. It could be the magnitude of x plus 2 all over x minus 3 less than 4. Okay, so again, you can equal this to 4 to see what you want, but again, I'm just going to square both sides. If I square both sides, again, I get rid of the modulus. So square both sides, I get x squared plus 4x plus 4 over x squared minus, 6x, not 9. The 9 comes later. 6x plus 9 is less than 16. Now remember, this thing is a thing squared, which means I know that this is positive. So I can multiply both sides by that to get rid of it. So I get x squared plus 4x plus 4 is less than 16 times this. So 16x squared minus 96 x plus 144. Again, I'm going to bring everything over to the right hand side because again, I just prefer positive x. So I get 0 is less than 15 x squared minus 100x plus 140. So I can divide everything by 5. So it's 0 is less than 3x squared minus 20x plus 28. Okay, this is probably going to be 4 and 7. Nope. Okay, 1 second. 3 x and x. Again, this is positive, which means both the things have the same sign and they have this sign, so they're both minus. So it's both minus, and the factors of 28, so it's 1 and 28, which is wrong. 2 and 14. Oh, 2 and 14 works. Okay, 2 and 14. So it's 2 goes here and 14 goes here. So this thing is going to be equal to 3x minus 14, x minus 2. Okay. So that means that we get that x equals 14 over 3 and x equals 2. Those are your two roots of the equation. So again, draw this out quickly. We get it's going to be 2 and 14 over 3, which is basically 5. So say that's 2 and that's 14 over 3. Again, the number in front of the equation is positive and therefore it's upward facing. And you want it to be greater than 0. So you want this and this. Therefore, I want x to be greater than this, so x to be greater than 14 over 3. Or I want x to be less than 2, because again, I want the x values that are left of 2, which means they're less than, and there's your final answer for those. Okay, so yeah, I think I'll leave it at that. And then I'll go over discriminants then in the next bit, which is kind of on about your minus b formula again. So yeah, thanks so much for listening, and I suppose I'll see you in the next video.